Do you feel the vibes?
All right, so we have been talking about polynomials, long division, and all that stuff, right? We learned about, right? We learned how to factor. Before that, remember, like if we just review a little bit, here we learned how to divide a polynomial by long division. And then we also learned synthetic division, okay? And so with synthetic division, we learned how to get a remainder and all that stuff. So we're gonna revisit that right now. So take a look here. We're gonna talk about synthetic substitution, which is a way in which we can use synthetic division to find the value of a function at a point. So for example, take a look at this one. We want to find f of 3 in this function in 3 different ways. The way in which we've always done it is by direct substitution, which means it would be 3 times 3 cubed minus 6 times 3 squared plus 3 minus 11. So this is 3 times 27 minus 6 times 9 plus 3 minus 11 is negative 8, right? So finally, right, this is going to be 81 minus 54 minus 8. F of 3 is 19, I believe, right? F of 3 is 19. So that's how we would do it. Okay, so we're going to now do it by long division. Okay, so for long division, what do we have here? We want it at x equals 3, right? Okay, so how do you get x equals 3? It's when you have a factor which is x minus 3 that you set equal to 0. That's how you get x equals 3, right? Okay, so here we're going to put x minus 3. And then here, 3x cubed minus 6x squared plus x minus 11. So this is good. We'll be reviewing some of this before the final, right? Or before the test even. So 3x cubed over x, 3x squared. Multiply, I get 3x cubed minus 9x squared. Now, here we got to change the sign and then add. So I get 3x squared plus x. 3x squared over x, 3x. 3x times x, 3x squared. And then times minus 3 is minus 9x. I got to change the signs though. So here we're going to get 10x minus 11. Some people had forgotten to do that. And then, obviously the answer does not come out correctly. So now 10x over x, 10. So here I get 10x minus 30. Change the signs. And what do I have left? 19. Look at that. That's the same 19. So f of 3 is equal to 19. Okay? Now, let me do another one and then what is your question?
I'm kind of confused on how 19 is our answer. That's the remainder.
I know. So there we go.
But it's the remainder, but the answer is...
Yeah, but that's the quotient. Okay? The division gives you the quotient, but the remainder is f of 3. Okay? So now let's do the same thing by synthetic substitution. So here we're going to have, inside, we're going to have 3, negative 6, 1, negative 11. So outside, we're going to have 3 because it's f of 3. The first 3 comes down. Multiply, you get 9. 3, 9, 10, 30, 19. That's the remainder. So f of 3 is equal to 19. Okay? So notice that the same value of f of 3 is obtained by all three methods, right? So whatever the graph of the function looks like, we don't know what the graph of this function looks like, but we know when x equals 3, f of x is 19. Okay? So that's how we can use the remainder, right, to find f of a function. So now, if f1, like if we were looking for like f of 1, it might be easier to just plug it in. But let's say I wanted to find f of 7. Now you're going to have to do 7 cubed, right? Times, and that is just not something that you can do swiftly by hand, right? So this method, if we use synthetic division to do it, is called synthetic substitution. And I want you to know that term, synthetic substitution, because on a test, if I ask you, find f of 3 by synthetic substitution, you have to do it that way. So now there are two ways. The way we used to do it traditionally is direct substitution. You directly plug it in, or synthetic substitution. Now, this also works. This is probably the least efficient way of doing it, so I probably won't ask you to do that. But you have to know the terms direct substitution and synthetic substitution, because on a test, if I've asked you, find f of 2 by synthetic substitution, and somebody raises their hand and says, I don't know what you mean here, I can't answer, right? Because that's what I'm asking for. Okay? Yeah.
What would be the difference between synthetic substitution and synthetic division?
Synthetic division, you're getting the polynomial, the quotient. So the answer would be 3x squared.
The final answer.
You get the quotient plus the remainder. This is just f of the value, so that just that number.
You're doing the same way, right?
Correct. Okay, but you're looking for different things. Yeah.
On the final, I know when it's going to be more of the unit 1 problems, would you specify what way we have to solve it?
Yeah.
Yeah.
Yeah. Right. I'll specify. If I haven't specified, you could do what you want. Yeah.
Oh, cool.
Also, like when we're doing the unit 1 stuff,
Okay.
and we have like a
Why don't I take? Huh?
Would we be using I during like the unit 1 section?
Okay. So. Okay. Hang on. Okay. Okay. So when okay, so let's take a look at this. Let's go back here now because I need like to focus our train of thought. So this told us, we don't know what this function looks like, but at x equals 3, okay, f of x is equal to 19. Okay, so what if I do this and I get a remainder of 0, right? That means if I get a remainder of 0, right? So if the remainder is 0, let's say like that would mean like f of 2, let's say, is 0, right? That means that x equals 2, right? The y value is 0. Does that make sense? So if I do synthetic division at a given point and I get 0, that means at x equals 2, the y value is 0. And if at a point, if the y value is 0, this is an x-intercept, right? That means if it's an x-intercept at x equals 2, that means at x minus 2, there is a factor of this polynomial. Okay? So, that's what this is saying. When polynomial long division produces a remainder of 0, the divisor is a factor of the polynomial. Okay? All right. So let's take a look here. Determine if x minus 3 is a factor of this. So let's see. Let's just focus on that. Is x minus 3 a factor? So x minus 3 equals 0. X equals 3. And let's see. 1, 4, negative 15, negative 18. 1 comes down, 3, 7, 21, 6, 18, 0. Okay, I get a 0 remainder, correct? That means f of 3 equals 0. That means yes, x minus 3 is a factor. Okay? So now, let's go back to what our question was saying. Determine if x minus 3 is a factor. Now it is. Now it's saying, if it is, identify the depressed polynomial and then find the other factors of the polynomial. The depressed polynomial is what you get after you do the synthetic division. So let's see. What is this polynomial going to give us? So from this, we know that one factor is x minus 3. From this, we're going to get x squared plus 7x plus 6. Okay? So now, f of x is x minus 3. And can I factor that blue further?
Yes.
X plus 1, x plus 6, right? So now we've found the other factors of the polynomial. So then what are the zeros?
-1 and -6.
Yes, x equals 3, x equals -1, x equals -6. So let's see where those are. -6, -1, and 3. Now it says to graph the function. Okay, so let's see how I'm going to graph this function. My leading coefficient is x cubed, right? If it's x cubed, it's odd. That means it's going to go up on the right side and down on the left side, right? So when I graph this, it's got to go here, cross this, turn around, and go up. Right? Do you see that? Do you see how we were able to graph really rather well this function? Like before today, would you have imagined that it was possible for you to be able to graph something like this? Not at all. Look at how complicated this looks. But look, we found one factor, we found the other factors, we got the zeros, we put the zeros, we know what the end behavior is because of the leading coefficient, so we can trace this out. The only thing we can't really know for sure without additional information is how high the maximum is or how low the minimum is. Okay? But that's fine because we just need, the other things to be precise. Yeah.
What if you weren't able to factor like x squared plus 7?
So you could do completing the square or quadratic formula, right? And you could put it into a non-graphing calculator and still get the points, like 1.63 and -2.68 or something. Okay, so now let's do it again. We are given a polynomial and one of its factors. Find the remaining factors of the polynomial, then graph. So here we go. X minus 1 is a factor. Why don't we do the division first? 1, -6, 11, -6. By the way, we should always be checking that, it's in standard form, the exponents are visible, are present, and so on. So here we put what number outside? 1. Now, this is a factor. What should the remainder be? 0. If you don't get remainder of 0 and you're told it's a factor, then it's a human mistake. So we got to go back and fix it. Okay, so 1, 1, -5, -5, 6, 6, 0. Fabulous. Okay? Yeah.
What's the right angle around the
Huh?
What's the square?
Oh, I just do that to isolate the remainder. So now from this, I get x minus 1. From here, I get x squared minus 5x plus 6. Okay, so this, right? This is called the depressed polynomial, but that's not like a state of mental, being or whatever, right? It just like because it literally got pressed down from the synthetic, like depressed, okay? Yeah. It's like a math pun, exactly. So now f of x is x minus 1, x minus 5, sorry, yeah, sorry, x plus 1, x minus 6, right? No, oh my goodness. Oh my goodness, I'm so sorry. I don't know where my brain is. Sorry. Yeah, oh yeah, look at that. So, okay, so the zeros are x equals 1, 2, and 3. The leading coefficient is x cubed, so it's the same situation. So 1, 2, 3. All right, so I know it's going to go down this way and up that way. I like to put those as my guide arrows. So now, we go up, back down, and up, and there you have it. Okay? Fabulous. Isn't that cool? Oh, you know what? Hang on. Hang on. We could do one other thing. Why don't we find the y-intercept? What's the y-intercept? Yeah, what would we get? 0, negative 6. So now we can do it even better. Right? We can do one better. Like that. Okay? Because for the y-intercept, you have to make x equals 0. So 0, 0, 0, negative 6. If x equals, you plug in, x is 0. All right. So this one just says, given a polynomial and one of its factors, find the remaining factors, right? Okay, so let's do this. Here we're gonna put 3, 1, negative 1, negative 5, negative 3. 1, here we put 3, 2, 6, 1, 3, 0 remainder. So this is going to be x minus 3, x squared plus 2x plus 1. So then this is x minus 3. How do I factor this? X plus 1 squared. Now, somebody always asks, is it okay if I write x plus 1, x plus 1? So, this is an honors class, so I would like you to recognize that this is x plus 1 squared, right? We want to recognize the patterns because that's going to be important later when we're finding repeated roots and so on. Okay, so here we go. We put negative 2 here. Well, what does it say? It just says find the remaining factors. These are the factors. It doesn't want the zeros. It wants the factors, so we're good. Yeah. It would, for now, you could just say negative 3 and negative 1. That's it. A positive 3 and negative 1, yeah. Okay? Yeah. For now, yeah. Okay, so here we go. For this one, I got 1, 2, negative 1, negative 2. Negative 2 out here. So 1, negative 2, 0, 0, negative 1, positive 2, so I get 0. So here I got x plus 2, and then what do I have here? X squared minus 1, so this is x plus 2, x minus 1, x plus 1. Yeah. Okay, let's pause here for a minute. So take a look at this function. if it doesn't specifically ask you to solve this using synthetic division, we could also have factored this by grouping, right? So here you can factor out an x squared and you get x plus 2. Here you factor out a minus 1 and you get x plus 2. So now this is going to be x plus 2 times x squared minus 1, and it's the same thing, right? So it doesn't, so if it just says, okay, so here's a function, like recognize that you can do it both ways. And they're both like equally acceptable, okay? All right, so let's take a look at this one. The approximate number of bald eagle nesting pairs in the US can be modeled by this function p of x. Look at this complicated function, right? They're not always going to be whole number coefficients, right? X is the number of years since 1970. Using synthetic substitution, estimate how many nesting pairs of bald eagles can be expected in 2018. Okay, in 2018, how much time has passed?
1 year.
Oh, sorry. 48 years.
48 years, right? So 2018 minus 1970 is 48. So what are we looking for then? We want the population at 48. So we want P of 48. Do you see that? Right?
Yeah.
Synthetic substitution or not, this is what we're looking for. Now it says, okay, find P of 48, but you got to do it using synthetic substitution. Until today, we would have just plugged 48 into here and done it that way. Okay? So now we're going to put 48 here. And here we're going to put negative 0.16, 15.83, negative 154.15, 1147.97. Okay, so negative 0.16 comes down. Okay, go ahead and take out your calculators. Multiply this. Because there are 2 decimal places for each of them, we have to go to the correct number of decimal places. So how much does that give us? Negative 7.68. So go ahead and subtract. $8.15. Okay, now I want somebody else to tell me the next one. We're going to multiply by 48. What are we going to get? 391.2. Oops. And then let's add 0.2. Okay, now somebody else. If we multiply, I got something else. I got yes. Correct. And then when we add, we get 12,526.4. So now, okay, so was this 1.4? Okay, so P of 48 is 12,000. Yeah, let me, okay. 0.4. But now the question is, how many nesting pairs of bald eagles can be expected? Here, you have to round mathematically correctly, right? So it's going to be around 12,526 nesting pairs. Got it? Okay.
Get how it's 0.4 there though, because it's 0.97 and 0.4.